Okay, so for our your turn problems on solving by the quadratic formula, I've got 3 of them here. Hopefully, again, you've tried them first. For this first one, there's lots of negatives in here, so it's easy to make a mistake. So we've got a is equal to -1, b is equal to -4, and c is equal to -1. So we have x equal our negative b or opposite b. So since b is already negative, that's going to make it a +4. Plus or minus the square root. Again, we've got -4 our b squared minus 4 times our a, which is -1, times our c, which is also -1, all over 2 times -1. Like I said, a lot of negatives in this problem, so it's really easy to mess up on those signs, so be real careful with it. So we have 4 plus or minus the square root. So if -4 squared, remember that this is always going to be a positive because you are always squaring it. So this is going to be a +16. Then we have a -4 times a -1. That's a positive. But then when you do a +4 times another negative, that's going to take it right back to being -4 over -2. So now we can do the 16 minus 4. So this is 4 plus or minus the square root of 12 over -2. Again, we want to break apart that 12. This is 3 times 4. This is 2 times 2. So we have a pair of 2's. That's going to come out here in front of our square root. We have a 3 that's left over. So this is going to end up being 4 plus or minus 2 square roots of 3 divided by -2 or over -2. So since this -2 will divide into both 4 and the 2, we're going to reduce this down, and that's going to end up being 4 divided by -2, which is -2, plus or minus. Again, honestly, that this negative, when you're dividing into this plus or minus 2, doesn't really affect it because you're already talking about having both the plus or minus. So you're just doing 2 divided by 2, which would be 1. And so we would just write the square root of 3. So these would be our two answers. -2 plus the square root of 3 and -2 minus the square root of 3. Okay, so the second one, again, already equal to 0, so we've got 2n squared plus n minus 2. So our a is 2, our b is going to be 1, our c is going to be -2. So n equals, and again, the only reason I'm using n here is because that's the letter I'm using in my problem. Other than that, my quadratic formula is exactly the same. So I've got my -b, so I'm going to have -1 plus or minus the square root of 1 squared minus 4 times a, which is 2, times c, which is -2, all over 2 times 1. So now we're going to do -1 plus or minus the square root. So here we've got 1 squared, which is still 1, and we're going to do -4 times 2, which is going to be a -8. So then a -8 times a -2 will give us a +16 over 2. So add that 1 and 16 together. We have -1 plus or minus the square root of 17 all over 2. Now in this particular instance, we can't really do anything to the square root of 17 because he is a prime number, so we can't break him down any more than he is. So we're actually done right here. We can go no further. Our two answers are going to be -1 plus the square root of 17 over 2 and -1 minus the square root of 17 over 2. Okay, so let's look at that third problem that we had for the your turns. Sorry about that. Now again, on this one, notice that I am not equal to 0, so the first thing I need to do is move that 13x and that -3. So we're going to subtract 13x from both sides, make sure we line it under the other x we have. So that's going to give us 5x squared minus 22x. That's going to equal to a -3. So now we're going to move that -3 over to the other side as well. So we're going to add 3 to both sides. So we're going to have 5x squared minus 22x plus 3 equal to 0. When you're doing this movement stuff where you're having to bring everything over to the x squared, make sure that you do put them in order. I don't think I said that earlier. Make sure it is always your squared, then your variable or your x, and then your constant. So that when you pick out your a, b, and c, you pick them out correctly. So a is 5, b is negative 22, and c is a positive 3. So again, we're going to have x equal to, so again, remember our formula is a negative b, so my b is already negative, so when I do a negative and a negative, that's going to give me a positive 22 plus or minus the square root of a negative 22 squared minus 4 times a, which is 5, times c, which is 3, all over 2 times 5. And again, this is probably a problem we might need to use our calculator on to figure out with these big numbers like 22. So we are going to have x equals 22 plus or minus the square root. Remember again, you are squaring a negative, so a negative times a negative is going to make that a positive, and that is going to be a positive 484. And then we have negative 4 times 5, which is negative 20, and then negative 20 times 3, which is a negative 60, divided by 10. So now we can subtract 484 minus 60, so we're going to get 22 plus or minus the square root of 424 over 10. And now we get that fun job, because we really do 424. If you check it on your calculator and try to do the square root, you'll find out that it is not perfect. So we do need to break that down. It can be a little challenging when you get a big number like that. But remember that it's an even number, so automatically it is divisible by 2. So you could break this up and say this is 2 and 212. So then you could do 2 again, since it's still an even number, and this is 2 and 106. You can break this down. Again, it still ends in an even number, so it's still divisible by 2. This would be 2 and 53. And 53 is actually going to end up being a prime number, so we can stop right there. We do have a pair of 2's. Remember, every time we have a pair, we're going to pull one of them out. And then we have this 2 and 53 left under, so that we are going to multiply those back together. So this is going to end up being 22 plus or minus 2 square roots of 106 all over 10. And one more thing, we're almost done with this problem. We're going to divide all three of these, the 22, the 10, and the 2, by 2, because they're all divisible by 2. All three. Remember, we have to do it if it's all, we can only do it if all three of them on the numbers on the outside are divisible by the same thing. So this would end up giving us 11 plus or minus the square root of 106, all divided by 5.